Yeah, so today I wanted to talk to you about basically a process that I started a while ago in our monolithic Django application. Um, yeah, so my name is Jeroen Stoker. Like the introduction said, I have a lot of experience with Django. At this point, it's basically the only real web framework I worked on working with Python. So it's basically Python and Django for me. It's kind of similar. So I've noticed this sort of trend happening in our monolithic Django applications that I noticed. And well, in the previous iteration of Pygrunn, there was a talk about GraphQL, and that basically inspired me to look at the problem in a different light. So that's what I wanted to talk to you about today. So first begin explaining the problem that I saw, and then I'll try to explain to you why GraphQL could be a solution for that problem. Yeah, so let's start. Well, basically, the Django project timeline in a really condensed way is you start a project, and sometimes you start with a single app, like a Django core app. It contains some models, some views, some URLs, maybe some templates. Sometimes you slap on some JavaScript or jQuery to the templates, and it's basically very simple. Sometimes you add some more apps to it, like for example fields or reports or whatever, to solve the needs of the business. So you can add some business logic to your Django project. And it can, in the beginning, can be quite simple. The front end usually just some included static JavaScript, some jQuery, data tables, whatever. It could be very simple. And then when time progresses, sometimes you want to add some more fancy front end. So you look at single page apps, maybe in Backbone or React. And to power those apps, usually you need something better than just a Django view. So then you look towards maybe a REST API, and maybe it's only for internal use, but maybe some more external use. But let's focus on internal use first. Yeah, so the Django web framework basically lends itself pretty good to a modular design where you can just add more layers to your application without having too much overlap with the existing code. In the reality, of course, there's lots of overlap, and it will never be a true onion. But yeah, this is basically what the idea is of layers. And when time progresses, at least in our situation, we tend to slap on some more REST APIs. So there's some more internal apps being made, and the old internal app REST APIs were perhaps TastyPy, a bit older. Maybe they were not functioning well enough. Maybe they had some other requirements. So we add on some more APIs. Basically, it looks the same as the old API, but there's some more newer frameworks being used, or some more ideas being implemented. And well, and maybe we add some more documentation to those APIs, so it will be a bit easier for front-end developers to know what's actually being served. And those APIs usually in our situation will even progress even further for example, mobile apps or external parties, and bring a lot of capabilities to a lot of people. But the big problem is that the front-end developers usually use the existing APIs and the existing data models. And for every new feature, they slap on some attributes to some views here and there, and they extend the serializer, so they have to add more endpoints to it. And then the front-end developers sometimes are also the back-end developers, the full-stack developers. And it can become quite messy and a bit difficult to know where you have to start, because you have maybe two internal APIs, and maybe you have an external API that is being set up with certain attributes, but maybe you want to delete one, and it can become quite messy to know where you have to start. So I wanted to focus more on the REST aspect of this structure. Well, the classic problem in REST is the under and overfetching problem. Where underfetching just means that when I am interested in information about the user, I only retrieve a certain slice of information about this user. And when I want to know more about the user, usually there's a nested endpoint for that, which you have to call again and retrieve more information about that. And the same problem can be there, is that there's not enough information in that response. It's called underfetching, where you have to call multiple endpoints to retrieve all the information that you need. And on the other end of this problem is that, at least in our situation, the REST APIs can become quite large. The responses can become quite bloated, usually because of some business logic that probably was a good idea to do that. But in the hindsight, it can become quite bloated, and it's called overfetching, where you have too much data in the response. So yeah, that became quite a problem. So when we were planning to start a new front-end app, I was looking at the code base and I was thinking, okay, now we have a whole new domain, for example. Where do we start? Am I going to reuse some internal APIs? Am I going to add more endpoints to those APIs? Am I going to reuse endpoints and add more data to those responses? And yeah, I was beginning to notice a big problem there. I also, if I'm going to change something about their APIs, I want to reuse as much business logic as possible. So I don't want to set up a new application. I just want to use the Django backend as much as possible. Yeah, and I also will prefer if it is being done in an incremental way. So I don't want to have a full big bang refactor of every front or backend or whatever. I just want to start at some point and then increasingly implement it in a different way. So like I said, in a previous iteration of Pygrunn, there was a topic of GraphQL, and it was quite promising. Basically what it boils down to is it's a specification for describing your data in a scheme and to execute queries. So what it comes down to is that you have a schema where the data that is being supplied by the endpoint of GraphQL server is defined, and the front-end developers can just look at the schema and know what data is available on that endpoint. It's a strongly typed schema, so you also know more about the fields. So instead of having to look at the backend, or maybe you have an open API, Swagger API documentation, you can just look at the schema and know what data is available. And with that schema, front-enders can define just the queries that they need for that moment. So you can have a very large schema, very large types, and you can just focus on maybe only the certain aspects of it. And other parts of the application can just use everything if they want. So it becomes very flexible to work with front-end, and GraphQL itself is also unapologetic. They are front-end first, basically. So they give all the power to the front-end developers. That's what it comes down to. Yeah. So what it compares to REST is instead of having to look to all the endpoints or all the domains that you need, you can look at the schema and you can know what data is available. You can also see all the relationships between the data, so you can compose your query to retrieve all the information that you need in a single request. So in this situation, the user and posts and followers, where in the previous overview there were multiple calls, it's now being done in a single call. And you can see comparison in the bottom left as well. How that looks on an architecture level. So yeah, it became quite clear to me that GraphQL could be a good solution for a situation where we had too much endpoints, too much REST APIs, and we didn't know really how to start. It could be a nice way to combine all the data models that we have in our legacy systems and just combine it in a single schema and make it possible for front-enders to basically just limit fetching the data that they need instead of getting all the data and have to combine it themselves. So there were a few ways to begin. I was looking around a bit. There are a bunch of tools like Hasura or PostGraphQL. They auto-generate a complete server for you based on the database that you supply. So you can just add on the server to your database and it will automatically generate a big schema for you based on all the tables in your database. It will automatically add CRUD operations to it. So yeah, that's a very quick and easy start. But like I previously wanted, it doesn't make it possible to reuse business logic, I still have to rewrite a lot of logic in those tools. So it made sense to me to stick to something that I know, and that's called Python. So there is also Graphene, and it's a more raw, Python-centric way of defining a schema. So how it looks like is, and it also fits more in the design of Django, where I can just add on a module to the backend and not, integrate it with the current code. So what it looks like is, I want to define a schema. So the first step is to define what is in the schema. In Graphene, you do that with object types. It's code first, so everything is done code. In the other tools here, it's sometimes a schema first, so you first have to define the GraphQL schema, and then it will, or configuration, but in this situation you just have to write some code. And in this example, it's very simple, of course, but it's the first slide. But yeah, what you do here is you define what is in the object type and what is being queryable on that query. So in this situation, I have a hello and goodbye properties that I can fetch in this schema. And in the bottom, you can see how it's being fetched. That's the syntax of this GraphQL query. So basically what it comes down to is you have to add some resolvers to resolve how a certain property of the API results in actual results. And you can do this for external APIs as well. So you can call external APIs in the resolvers and return all the data that is being returned there. And so you can actually also slap on some proxy behavior on the GraphQL scheme. Okay, but we don't want to do this for every Django model manually. So let's begin with a little demo. Well, the background of Cropix is farm, so just use some farm names here. But it comes down to that you have a farm. It's basically the group that the person belongs to. It can be owned by a person. You have some fields that belong to that farm. There's a relationship there. And each field can have maybe a label or two. And yeah, they can be owned by farms. So there's some relationships being defined in Django, and yeah, it's basically very straightforward, I guess. This is all being mapped one-to-one, of course, to the database manually, automatically by Django. So Graphene Django, that's an extension of Graphene. It works on the concept of adding data to the schema in a code-first approach, and they provide some abstractions to make it way more easier to configure your scheme. For example, you have a Django object type that automatically maps all the relationships that are being recorded on the query, and it also auto-resolves all the fields that are on the models. So yeah, it's basically just, it looks like a DjangoRestFramework model serializer, but yeah, it's very quick to start. And how it works on the water is that every field that is being registered on the model is being evaluated by Graphene Django, and it is being mapped into the scheme, and it will auto-generate basically documentation for you. You don't have to worry about what data types to use in the scheme, it will map it for you. But there are some exceptions. Sometimes you have geometry models, for example, or fields, and they are not automatically converted. There are some extensions for that, but I won't go into that more. Okay, let's see. Yeah, so in the next step of after you define a query per Django app, basically you just combine those queries into another query, and that query will form the basis of your GraphQL view. Yeah, it's pretty straightforward to start, but it will become way more complex later on. So what it does is now you have configured the schema. It's very simple. You had added some models to your schema, and you combined those schemas into a single query. And what Graphene does is that it detects those models and it generates for you a type system. You have a command for that, and you can see what is being generated in the schema file. So I'll attempt to do a little demo. Let's see. Let's see, restart code space. Yeah, so in this example application, it's very simple. It's just a basic Django app with some Django project with 2 apps in it. I already mapped the view. So in this situation, you can see that the view is already being defined. I'll just spin it up. And like I previously showed in the slides, that it's all being mapped here in the schema.py files in each app. So that's the most important starting point of this implementation, is that every app itself is not, it can function without the schema.py. So this schema.py is just imported in the single schema.py in the root file, but it should serve as a layer on top of the current logic, not as a integration. I think it's already running now, so I can show you a playground. So GraphQL, of course, Graphene, and GraphQL itself also, I think, defines a protocol for GraphQL. It's a playground to look around the schema and to define some queries and mutations and other things you can do with GraphQL. And the nice part about this is that it adds some introspection to your schema. So you can see what is being done, what is being registered on the schema after you run the server. So in this case, I only have a query defined. There's also some other root types I could add, but at the moment I'll stick to queries. And here you can introspect all the types that has been added to the GraphQL schema. And you can click on it and see all the types and all the fields that is available on this schema. And here you can also define some queries that you want to make. So for example, I want to know all the fields on a certain page, for example. What I do then is I can type here and it will autocomplete all the elements that are available in the schema. And the notation is as follows, that you can open the brackets and then you can define the fields that you want to get from those fields. Well, for example, I want to down the name and maybe also some, maybe also the labels. Maybe color. Yeah, so you can see the response on the right side here. So you can see that the models has been mapped completely. All the fields that are available on the models are mapped automatically into the schema by Graphene Django. It's up to developers, to the front-end developers, to define what fields they actually want to use. And yeah, that could become a problem in the future. So I'll just switch back to the presentation. All right, let's continue. Okay, so that's a little demo setup for a start of a Graphene endpoint. It's really simple. But what it comes down to is that I had a modular approach to Django and I just added a layer to it, the GraphQL API. It should not overlap too much with the current code base, but of course I added some schemas to the apps, like you see in the lower right here. Yeah, but what this makes it possible to, yeah, to basically think about front-end in a different way. I'll just add some more post-adoption feedback. Maybe I should have started with this a bit earlier, but yeah, so there's a bit, it's very easy, like I just showed you, to start. But it's also easy to make some big mistakes in the beginning. For example, security. You can forget this part and release your Django app and then discover that someone who is a bit more technical can retrieve all the information of your backend without any limitations, because Graphene doesn't filter data by default. You have to implement that yourself. So what we did is we overrided the get query set methods of the object types to look at the rights of a user. But there's also a way to do it on database level, for example, row level security. Probably a better solution. We still haven't done that, but you can then define roles, or no, you can I forgot the word. But you can configure what rows can be requested by user without doing on a business logic level, but move it to the database level. And there's also an important part in Django that you got cross-site request filtering protection. That means that you cannot do requests from other places than your own application. You should not exempt that. Some tutorials just basically automatically add that to your code, but you shouldn't do that. You should ask the DevOps guy to help you set up the IP addresses. Also a big problem that I noticed after implementing GraphQL is the optimization and the lack of it. After you implement a very large part of your application and you can allow front-end people to do large queries, you start to notice that it is very slow. And that is pretty much explained by the inefficient way of querying the data by Graphene. There's some ways to resolve that. You can, for example, use data loaders. Data loaders comes down to is that you defer loading of models after the query has been analyzed by Graphene. And then at the end, when all the IDs have been collected, you can just bulk load them in. And that's a bit more efficient. There's also some other ways to do that I haven't gone into. Data loaders were good enough for now. But there's also ways to batch process queries, and there's also a way to asynchronously process parts of the query. So there's more tools to be used here. But data loaders was the big breakthrough moment for us to address performance. Yeah, 2 minutes. There's also filtering capabilities. Didn't really show you yet, but there's some nice plugins you can use for Django. And you can extend your queries so you can add basically infinite amounts of filtering capabilities. I'll just skip this one. And yeah, so the nice part of GraphQL is that the front-end developers have a way to actually define on component level with certain libraries. It's probably easier than others, but I use Relay Dev. It's very nice front-end framework, and you should really look into it. And what it allows you is to define, like the promise I made in the beginning, you can define the data that you need for the component, just for this component, only this data. So yeah, that's very nice, and it has a lot steep learning curve, but it's really worth looking into. Okay, so let me just wrap it up then. Yeah, I was quite inspired by the talk a few years ago about GraphQL, mostly because I was really tired of adding endpoints and serializers to our old legacy system. So it promised a lot of good things, but it also introduced a lot of problems, mainly the optimization part. Security part was not that difficult to address, but yeah, you should really look into the impact it can have. We have just basically an open SQL way of retrieving data. So people should not have that much control over it. So you should look into configuring your APIs. So yeah, that was it. Thank you.